let's finish off the question in this video. So we have now part C, the integral of 3 over x dx. Let's do it over here. The integral of 3 over x. What is 3 over x? That's the same as 3 multiplied with 1 over x dx. Now we have to keep in mind that we can use another integration property with 1 over x, something related with logarithms, because this is the same as 3 times the integral of 1 over x dx. Remember, we can take the constant out, but we have a special property for the integral of 1 over x dx. When we have such integration, the result is just ln of x plus c. And if we check that, then indeed the derivative of ln of x, we know that that's just going to be 1 over x, and the derivative of the constant is just 0. So we would get back to the original function. In other words, the result of this integration would be 3 multiplied with the logarithm of the absolute value of x plus the constant. Hope this makes sense. We did that. Let's do d as well. So the integral of a times e to the power bc dc. Okay, that sounds a bit odd, but it's gonna make sense. So let's do it over here in part d. The integral of a times e to the power of bc. So e to the power of bc, and we're integrating with respect to c. What would be a first step to do over here? Well, we can take the constant out. That would be the constant, right? So we have a times the integral of all the rest, the integral of e to the power bc and dc, or times dc, better said. Now we're going to use the the integration property of the natural number e. And that is that the integral of e to the power of x dx is equal to e to the power of x plus a constant. But what we have in this case is not just e to a certain power. It's, in our case, c is the variable, so c is the same as x. So we have e to the power of b times c times dc, and we can see that it's a bit different than what we had over here, because we had only one variable, but now we have our variable of interest c multiplied with a constant, multiplied with b. And what we do in this case, we have to multiply with a constant, and that's going to be 1 over b times e to the power of bc, e to the power of bc plus a constant. And the reason we do so is because after we differentiate this expression, we will get back to the original. Let's just do it to prove to ourselves. We have 1 over b times e to the power of bc plus a constant, derivative with respect to c. So how does that work out? Well, let's see. We will differentiate every term. 1 over b times e to the power of bc. We keep the constant, 1 over b. We differentiate e to the power of bc, which is e to the power of bc times the derivative of the power, because we're using the chain rule. So bc derivative with respect to the constant, and then plus the constant derivative is just plus 0. Now what do we have as a result? We will have 1 over b multiplied with e to the power of bc, so e to the power of bc, times the derivative of b times c with respect to c. We just keep the constant, and the constant is b in this case. And what we can see now is that b and b go away, so b and b cancel out, and as a result we're left with e to the power of bc, and that's exactly what we had in the original function of the integral. That's what we wanted to integrate. We have it over here. So indeed our thing worked out. Now, how does this apply to our function? Because we actually just solved it. Well, we will keep the constant a, and when we integrate e to the power of bc times dc, well, we saw that the result over there would be equal to 1 over b. So we have 1 over b times e to the power bc, and then we add a constant. So plus a constant, and that would be the result. And we are done.